In Part 2A of our discussion, we examined the ampacity of 600 kcmil and larger single-conductor cables in cable trays, both uncovered and covered. Now, let's delve into the ampacity of 1/0 AWG to 500 kcmil single conductors when installed in a cable tray, in both configurations. Without further ado, let's get started. Subsections 392.80 A, 2, B. When installed in accordance with the requirements of 392.22 B, the ampacity for 1/0 AWG through 500 kcmil single-conductor cables in uncovered cable trays shall not exceed 65% of the ampacities listed in Table 310.17 and Table 310.19. If these cable trays are continuously covered for more than 1.8 meters, 6 feet, with solid, unventilated covers, the ampacity for 1/0 AWG through 500 kcmil cables shall not exceed 60% of the ampacities specified in Table 310.17 and Table 310.19. For 1/0 AWG to 500 kcmil single-conductor cables installed per 392.22 B in uncovered cable trays, the ampacity shall not exceed 65% of the values shown in Table 310.17 and Table 310.19. If the conductors are covered for more than 1.8 meters, 6 feet, with solid, unventilated covers, the ampacity must not exceed 60% of the values listed in Table 310.17 and Table 310.19. Let's use an example based on Table 310.19. A 2/0 AWG type FEPB single-conductor cable has an ampacity of 467 amperes in the 200 degrees Celsius column. When these cables are installed in a cable tray according to Section 392.22 B and uncovered, the ampacity is reduced to 467 amperes multiplied by 65%, resulting in 303.55 amperes. Please note that this ampacity is based on an ambient temperature of 40 degrees Celsius, 104 degrees Fahrenheit. If the cables are covered for more than 1.8 meters, 6 feet, with solid, unventilated covers, the ampacity is further reduced to 467 amperes multiplied by 60%, which results in 280.2 amperes. Let's determine the minimum width required for a ladder-type uncovered cable tray that holds 5 circuits rated at 300 amperes, using Type PFA single conductors arranged in a single layer. To find the appropriate conductor size for the 300 amp circuit based on Table 310.19, we consider a maximum of 65% of the listed ampacities. Dividing 300 amperes by 65% gives us 462 amperes. According to Table 310.19, a 2/0 type PFA conductor, rated at 467 amperes, is suitable for this application. The outside diameter is referenced from Chapter 9, Table 5. The outside diameter of a 2/0 AWG PFA cable is 0.508 inches. For 15 cables, the total outside diameter is 7.62 inches. As per Table 392.22 B1 of the NEC, given this total outside diameter, the next standard tray width that can accommodate it is 8 inches, 200 millimeters. Now, what if part of this cable tray is covered with solid, unventilated materials for more than 1.8 meters? What would be the necessary width of the cable tray in this case? To find the appropriate conductors, we divide 300 amperes by 60%, resulting in 500 amperes. According to Table 310.19, a 3/0 type PFA conductor, rated at 546 amperes, is suitable. From Table 5 in Chapter 9 of the NEC, the outside diameter of a 3/0 AWG cable is 0.56 inches. For 15 cables, the combined outside diameter is 8.4 inches. Based on Table 392.22 B1, the minimum width required for the ladder-type cable tray is 9 inches, 225 millimeters. Thank you all for watching.